Dear channel family, welcome to this channel. I hope you gained the necessary knowledge about natural numbers in our last lesson. Today we will learn thoroughly about integer numbers. If you are new to the channel, become a member by subscribing, and I humbly invite you to answer 10 top questions derived from the topic we discussed today. I am Undasan Worku. Enjoy. Integers, denoted by the symbol z, are the set of all whole numbers, both positive and negative numbers, together with zero. They form one of the most important number systems in mathematics because they allow us to handle gains or losses, temperature changes, depths, elevations below sea level, and much more. A standard definition for integers. Integers is equals to started from negative infinitive. For example, negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5, up to positive infinitive. The symbol z comes from the German word Zahlen, meaning numbers. There is no disagreement about the definition, or unlike natural numbers, z always includes negatives, zero, and positives. No fractions, no decimals. Integers is equals to natural numbers plus zero plus negatives of natural numbers. If your earlier natural numbers started from 1, then z started from negative infinitive. For example, negative 3, negative 2, negative 1, union with 0, 0 union with 1, 2, 3, up to positive infinitive. Key characteristics of integers. They are whole numbers, no fraction or decimal parts. They extend infinitely in both positive and negative direction. They include 0, which is neither positive nor negative. They are used when direction or signed quantities matter. They never include fractions like 1 over 2. Decimals like 3.7, irrational numbers like square root of 2 or 5, or complex numbers. Main properties of integers. Under the 4 basic operations: addition, subtraction, multiplication, division. The first property, closure property. Integers are closed under addition, subtraction, and multiplication. The result is always another integer. For example, 7 plus negative 12 is equals to negative 5, integer. Negative 8 minus negative 3 is equals to negative 5, integer. 6 times negative 4 is equals to negative 24, integer. But not closed under division. For example, 8 divided by 3 is equals to 2.666, not integer. Commutative property. Order doesn't matter. Addition, a plus b is equals to b plus a. Multiplication, a times b is equals to b times a. Subtraction and division are not commutative. For example, 5 minus 3 is different from 3 minus 5. Associative property. Grouping doesn't matter. Addition, a plus b inside the bracket plus c is equals to a plus inside the bracket b plus c. Multiplication, a times b inside the bracket times c is equals to a times b times c inside the bracket. Subtraction and division are not associative. Distributive property. Multiplication distributes over addition or subtraction. A times inside the bracket b plus c is equals to a times b plus a times c. A times inside the bracket b minus c is equals to a times b minus a times c. Identity elements. Additive identity is equals to 0 because a plus 0 is a. Multiplicative identity is equals to 1 because a times 1 is equals to a. Inverse elements, very important differences from natural numbers. Every integer has an additive inverse or opposite number. The sum of a number and its opposite is equals to 0. For example, 7 plus negative 7 is equals to 0. Only 1 and negative 1 have multiplicative inverses inside integers. Most integers do not have multiplicative inverses in Z. Comparison and order. Integers are totally ordered. Any two can be compared with, less than, greater than, or equals to. 5 best and most illustrative real-life examples of integers. The first example, bank account balance. Positive, 0 or negative. You have 5,000 cash in your bank account. Positive integer. Your balance is 0. Or you have 2,300 overdrawn or in debt. Negative integer. The second example, temperature readings in Celsius. Positive 28 degrees Celsius. Warm day. 0 degrees Celsius. Freezing point of water. Negative 12 degrees Celsius. Cold winter nights in Addis Ababa highlands or elsewhere. The third example, elevation or altitudes above or below sea level. Positive 2,355 meter elevation of Addis Ababa. 0 meter sea level. Negative 430 meter dead sea shore below sea level or negative integer. The other example is score changes in games or quizzes. Positive 15 points for correct answers. Negative 4 points for wrong answer or penalty. Net score can be positive, 0 or negative. The last example, floor numbering in buildings, especially with basements. Floor 5, positive. Ground floor, usually 0. Basement level, 2 or negative 2. Integers are the first number system, where we can subtract any number from any other number and stay within the set, or unlike natural numbers. This makes them essential for algebra, coordinate geometry, physics, economics, and computer science, especially signed binary representation. Question number 1. What is the standard symbol used to denote the set of integers and where does it originate from? A. Capital N from natural. B. Capital Z from the German word Zahlen, meaning numbers. C. Capital R from real. D. Capital Q from quotient. The correct answer is answer B. Z from the German word Zahlen, meaning numbers. Question number 2. Which of the following best completes the description? Integers is equals to natural numbers plus 0 plus question mark. A. Fractions of natural numbers. B. Negatives of natural numbers. C. Decimals of natural numbers. D. Square roots of natural numbers. The correct answer is answer B. Negatives of natural numbers. Question number 3. Which of these numbers is not an integer? A. Negative 7. B. 0. C. 4.5. D. 12. The correct answer is answer C. 4.5. Explanation. Integers have no fractional or decimal parts. Question number 4. Under which operation are integers not closed? A. Addition. B. Subtraction. C. Multiplication. D. Division. The correct answer is answer D. Division. Example. 8 divided by 3 is equals to 2.666, which is not an integer. Question number 5. Which property states that The order of numbers doesn't matter for addition and multiplication of integers. A. Associative property. B. Commutative property. D. Distributive property. D. Closure property. The correct answer is answer B, commutative property. For example, A plus B is equals to B plus A, and A times B is equals to B times A. Question number 6. Which property doesn't hold for subtraction of integers? A. Closure. B. Commutative. C. Identity with zero. D. Distributive. The correct answer is answer B, commutative. Example, 5 minus 3 is equals to 2, but 3 minus 5 is equals to negative 2. So order matters. Question number 7. What is the additive identity element in the set of integers? A. 1. B. Negative 1. C. 0. D. There is no additive identity. The correct answer is answer C, 0, because A plus 0 is equals to A for any integer A. Question number 8. Every integer has an additive inverse. What is the additive inverse of negative 12? A. Positive 12. B. Negative 12. C. 0. D. 1. The correct answer is answer A, 12, because negative 12 plus positive 12 is equals to 0. Question number 9. Which real-life situation is best represented by a negative integer? A. The elevation of Addis Ababa at positive 2,355 meters above sea level. B. A bank account overdrawn by 2,300. C. A temperature of positive 28 degrees Celsius on a warm day. D. Gaining of positive 15 points in a quiz. The correct answer is answer B, a bank account overdrawn by negative 2,300. Negative integers represents depths, losses, or below sea level elevations. Question number 10, or the last question. In which real-life context are negative integers commonly used for floors in a building? A. Top floors above ground. B. Ground floor labeled as 0. C. Basement levels labeled as negative 1, negative 2. D. Rooftop gardens labeled as positive. The correct answer is answer C. Basement levels labeled as negative 1, negative 2, etc. Example, basement level starts from positive 2 up to negative 2, showing signed quantities and direction.